Alright, in this video we're going to talk about repo carry adder with its architecture. We're going to talk about structural design of the repo carry adder and behavioral design. What are the difference between those two designs and the cost of the implementations. If you remember in our previous design, when we designed neuron model, we had 3 read and writes. So and then when we add those 3 read and writes, we had a sum of 3. So you can see this is like you have an addition of in a column or a row, you can call it. So it's only 3. The maximum input that you have. For example, now if you're gonna add 15 10 writes, how will you implement this? This is the easy way to do it, to use repo carry adder. So now we're going to talk about structural design. So if we have if you're going to add 15 plus 15, you can call this x, x0, x1, x2, x3. You can call this y, y0, 1, 2, and y3. If you want to sum this one, so we know here this is 2 to the power of 4 minus 1 is 15. So now here we're gonna just add the summation the way we do in normal arithmetic summations. So now you can see here we have 1 plus 1 in bit. So 1 is 2, but we have only plus for 1 bit here, so you need to write 0 because it's 2. So 1 plus 1 is 2. So if you can take a look here, 1 plus 1 here, so you have 0 and you have a carry. So this is a sum carry, you can call this is our y, x, and carry in. Now you can see here we have a carry, so you can call this row here too carry. So you can call this is our carry in. Here we didn't have our carry because it is 0. So you can see the way you add this is you have 1. So 1 plus 1 plus 1. You can refer to the table again. You can see this is 1. And then you have another carry. And then you have a 1 here. And then you have another carry. And then you have a 1 here. So this is a summation of 4 bits. So you can call it n bit. But here we have a carry again here because we have a 1 here. Here this one will, if you add 15 plus 15 in 4 bits, it will show you that you have 14. But you remember you have another bit here because here is, you can call it 0 and 0. And then if this last bit, that is in kind of way gonna be a carry out because you have a carry. This is a 16 bit. So if that one here is a 16 bit, so if you add those two, you will have a 30. So you can see here you will have a 30 answer. In kind of way you can see this one is a full adder. So you have how many full adders? You have a full adder, 1 2 3 4, 4 full adders to perform a 4-bit adders. So how will you design an architecture of this one? This is the way you have set up like this one. You can just design the architecture. For example, here we can, so this is our first full adder, our second full adder, the third one, and the last full adder. And then you can see clearly that this 0 here, it was our carry in, this one, and here you can see this is our carry 1 2 3 and carry 4. So we have a carry 1, carry 2, carry 3 and carry 4, which are these ones here, which are up here. And then this is our x zeros and y0, x1, y1, x2, y2, x3 and y3. And last here we have our sums, sum 0, sum 1, sum 2 and sum 3, which are down here, or sum. So this is how you will design a repro carry adder structural way, because this have all, it have a logic blocks inside these full adders. So this is this is how you design a repro carry adder. And then we can, in the next video we'll talk about how we're gonna program this one in Verilog file in Quartus.